Taking pictures of the geese. They're hungry. What?
The little ones. The little ones.
Yeah.
The little ones. The little ones.
Uh-huh.
Hey.
Hey guys, welcome back to Fortified Castle. Today we're going to be talking about coatings, all about coatings. You know, we get these knives, they're colored black. What is that? What is that coating? Why do you need to have a coating on there? A lot of guys don't like to have coatings on there. I'm one of them. I prefer to have a regular steel blade, and I just oil it and take care of it. And the reason is that these coatings can wear off, and so they look unsightly. You'll get part of the coating on there and part of it is gone. A lot of guys don't go through the trouble to completely remove the coating, or they don't know how to do it, and so they're just stuck with that nasty looking knife blade. So I already did this video. It was way too long. I'm going to try to shorten it up for you. And so when you're talking coatings, there are three basic areas that you talk about when you talk about coatings. One of them is finish. And so it looks like a coating, but it's not a coating. It's a finish to the blade. So nothing is applied to the knife. It's just something that they do to the steel on the knife to create a finish. And so that's one area. The second is treatment. And the way to think about that is, I know a lot of you guys like to do patina your natural colored blade. So you get a blade that is brushed stainless or mirror polished like this, and you stick it in vinegar, and it creates kind of a silver looking matte color to it. And that is a color resistant coating, patina. It's a natural process that the metal goes through. And so that's what you're talking about when you're talking about treatments, blade treatments. And so then you get into coatings. A coating is something you actually apply to the blade. You're coating it. And there's a lot of different options there that your knife could be. And so you have metal coatings like silver coated or nickel coated, chrome. Those are all metal coatings on the blade that offer corrosion resistance. Then you get into coatings like titanium nitride. If you look at a drill bit, sometimes you see these drill bits that are gold. That's titanium nitride, and they harden the steel of the drill bit so that it'll wear less and last longer. And those are coatings that they put onto blades. You have PVD coatings. Those are physical vapor barrier coatings. And there could be different things, different chemicals involved in the PVD coatings. And then you also have DLC diamond light coatings. And there's some other more obscure coatings that are just coming out. Basically, these are all chemical type of coatings. It's just a little different in the way that they're applied. And so we're going to talk about that real quick. Okay, so in finishes are more cosmetic. They rarely offer any corrosion resistance whatsoever. The exception to that is this finish right here, a mirror finish. And so this is created by successively fine finishings of the blade that terminate usually between 1500 and 2500, but you can go up from that. Creates a mirror finish. The lower grit you go, or I'm sorry, the higher grit you go, the deeper the finish. That does offer some corrosion resistance, because what you're doing is closing the pores on the metal so that air cannot interact with the metal and create a corrosive process. So mirror finishes do have a small anti-corrosion type of benefit. This finish right here is, let me see, let me hear. This is a brush finish. This is where what I call half finished blades. And so what they do is when they clean the blade up from forging, they grind it to about 350, 320, 320 grind, and then they just clean it up and polish it a little bit. And that's what a brush uh, stainless finish is, or a satin finish. They also call it that. Here's another finish. This is a stonewash finish. Stonewash finishes are where they take the blade and they tumble the blade in a medium, usually ceramic, and it creates this kind of ripple look on the blade. Basically, that works for the manufacturer because it hides imperfections in the blades and it's attractive to us, but there's really no corrosion benefit. This is a black wash blade. So what they've done here is they've taken the blade and they've done an acid treatment on the blade, creating the black color, and then they stonewash it, and that's what a black wash blade is. It's just a stonewash blade that's been treated beforehand. Actually, the black wash blade could have some corrosive benefit. On this blade here, what you can see is a combination. So you have brushed stainless there, or satin finish, and then you have a stonewash finish. Again, it's all aesthetic. It's not really a corrosive protection. So unfortunately for the treatments, I really don't have an example for that. So the best example is bluing, right? So we all have seen weapons that have been blued, pretty deep black or blue color. This is actually a chemical treatment. And what they're doing with this chemical treatment is they're causing the knife to rust rapidly. That creates what they call manganites. And so that is a elemental type of reaction with the steel and is actually rusting the blade. But those magnetites cover the blade and they have an anti-corrosive effect. So bluing works, it's just not very durable. Another type of chemical treatment is parkerization. So with bluing, you're basically using acids and salts, and with parkerization, you're using manganese and phosphate. And so that is a little more durable than bluing. It works a little bit better. You tend to get kind of a green color overall in the blade. And so those are chemical treatments. And when you take a blade like this and you stick it in the mustard or you stick it in the vinegar, that is causing a rapid rust of the blade. Now, usually we don't get to the point of that you do in bluing or parkerization. So what we're looking for is what's called a patina, which is the beginnings of the decomposition of the metal, which produces a protective coating on the metal. And so that when you force patina a blade, that's actually a chemical treatment of the blade, right? You're acid washing it. And so when you go up from these treatments, you get into coatings. This is a fairly old knife. It's a fruit knife, and it is coated in silver. So this is silver plated, this knife right here. And so they did that because they knew early on that carbon steel rusted, and that's pretty much all they used was carbon steel. So they coated it in different metals, and that provided resistance to the corrosive effects of the acids that are found in fruit. This knife here is coated in nickel, and so actually the whole knife is. This is a coating we put on firearms sometimes. It's very pretty, and it's durable, and it provides excellent acidic and salt corrosion resistance. So you'll find nickel coated blades on old knives from the early 1800s all the way up into the 1900s, where they've plated these blades in nickel to provide corrosion resistance. Putting metal on metal is an electrolysis process, and it's expensive. Okay, plating metal is expensive. And so in the 20th century, they looked for better options. I'm not really sure how old powder coating is. It was either started with the auto industry or the aircraft industry, but powder coating works, and it's a very durable coating. This is a powder coated blade on this right here, and powder coating is an electrolysis process. So they run the blades into a chamber, and they negatively charge the blade and positively charge the paint, and so you have an electrical bonding to the knife. And this is a powder coat right here. They can be glossy, but they tend to be kind of matte color on blades. But they can be glossy too. And in this case, it's purely aesthetic. This is a stainless steel on this knife, and it has a sand kind of color, and the black just looks good. So they didn't have to coat this knife at all. They did it just to provide an aesthetic appeal to the knife. But other times, there's other reasons for these coatings, like provide strength to the blade or actually corrosion resistance. Another early type of coating is titanium nitrides. And so these are chemical coatings, a lot like a treatment that we would consider a treatment. But this SOG knife is titanium nitride. And let me zoom in here. And so this knife I got this knife and it has a rattle. I don't think you can hear it, but the handle rattles. And rather than take the time to tighten that up, which I could have done, I decided to use this knife for digging. And so I metal detect. And when you find a metal source in the ground, you got to dig it out. And this is what I use. I just dig this into the ground. It does a really good job. But what I want you to notice is that the coating is not worn off. And so you can see like scratches where things have scratched and left marks on the coating, but the coating is not wore off. And so these are very durable coatings. And if you look here, you can see right at the tip, it's kind of worn off a little. That's it. And I've been using this knife close to 4 years in metal detecting, digging holes all the time, and the coating is still on there. So these coatings can be really, really durable. Titanium nitride coating. There's also titanium carbon nitride, which is blacker. Titanium nitride kind of looks blue. It's kind of like a bluing. Next, you have PVD coatings. This little Kershaw here is a PVD coating on it. You can see it kind of looks like plastic when you look at it, right? And so it's rounded all the edges. And what this is called a physical vapor deposit, PVD, physical vapor deposit. And again, it's a type of paint that is applied to the blade. And oftentimes these PVDs will have ceramic in them. So like this knife is very kind of slick, right? It adds a lubricity to the blade. Cerakote is the same way. Cerakote is kind of matte and rough, but it's kind of slippery too because of the ceramic inside the coating. And so these are applied in a vacuum, and I'm not really sure how that works, but the vacuum provides kind of a really good adherence or coating between the paint and the metal. And DLC, I think, is supposed to be a PVD coating, actually. I'm not really sure about that, but a lot of these processes use this PVD type system to coat their blades. And there could be different coatings too. So there's titanium nitride, there's uh, tungsten. I think the newest one is a tungsten chloride coating that's PVD coated onto the blade. So the PVD is the process, and then the chemical that they use is often designated, titanium nitride or tungsten chloride, something like that. And finally, you have DLC coating. So this is a Hogue Dema with a DLC coating, and it's called diamond light coating. And I believe this is applied like a PVD coating, but DLC coating is usually only put on premium knives, and these are really increase the strength on the knife. So a DLC coating, take a knife that is 60 HRC. A DLC coating can run that up to 80, and that's incredible. So when you go from HRC codes or ratings are kind of like earthquake ratings, right? So when you go from 6 earthquake to 7, it's like a factor of 30, right? It's not a factor of 1. And the same is true with HRC. So when you go from 58 HRC to like 61, it's geometrically stronger, right? Much stronger. So to go from 60 to an 80, 85 HRC is just phenomenal. And so these coatings, especially DLC coatings, can really add a lot of strength to a knife. So, if you're dealing with these superior steels, why do you even care about that? Well, you take a knife like this, you see the sculpting on this knife? And so when you start cutting into this steel and bringing it down to the same size as the edge of your blade, you see that? See how it's sculpted? And then they've cut into here very deeply, by the way. That's a very deep cut because it's like that on both sides. And so you have a pretty minimalistic piece left here. Can you see that? And so if you DLT coat this knife, you're going to make this stronger, and that's going to help so you don't have this steel, you don't have that steel breaking, right? And so DLT coatings are definitely good on custom knives where you have a lot of sculpting or holes in the knife like this right here, where you've scalloped the knife. That's going to add a lot of strength to your blade. Another thing is you can use cheaper steel, right? So if you take a lesser steel like HCR 15 and you DLC coat it or you titanium nitride coat it, you're now taking a steel that's usually in the 54, 55 HRC range, and you now turn it into a super steel. It's a lot tougher, a lot harder. And so that may be a reason why you might see some of these coatings on lesser knives. And so you're going to coat a knife, one for aesthetics, right? Just because it looks good. Another reason is on a knife that's a high carbon steel. Say you have a hard carbon steel that's used in the outdoors, a hunting knife. Titanium coating on that knife would really benefit the knife. It's going to give it some corrosion resistance, and it'll also strengthen the knife. And then the last reason is just to make a stronger knife by coating it with one of these titanium coatings or DLC coatings or PVD coatings. Lastly, a blade can be anodized, and so you see here This is an electrical process where electricity is run through the metal. This is a titanium handle. Electricity is run through it, and depending on how long you leave that electricity running in there, it'll make blue color is typical, but the longer you leave it on there, the more color you get, and so you get these different purples and yellows and golds in the steel. And so usually that's not really a good thing on a knife blade, because you're heating it up and you can take the temper out of the knife blade. But normally where you see anodized blades is in custom knives, or a high-end knife that guy's typically not going to use hard, right? So they're $600-700 knives, and the blades would have a design on them created by anodizing. Doesn't really do anything to the knife. I think they probably hurt the knife by affecting the temper on the blade, but that's just my opinion. And then, anyhow, I hope you found it informative. Really complicated subject. So I've tried to rush through. I'm sorry the video is so long. If you'd like to see more content like this, go ahead and subscribe. I'd love to have you to the channel. And thanks to all my friends for supporting me. And you keep coming back. And so I'm going to keep making the videos for you. Thanks again.